Alright, this is the second part to my first series for civil analysis. I'm just going to be solving the next question today. It's going to be this one right here, y double prime plus 8y prime plus 16y equals 0. And it shouldn't be too much trouble to solve this. Very similar to the last one, but I'm just trying to show the concept of how these homogeneous equations work, and then we'll go forward in the next few videos looking at some harder examples, and then we're going to look at particular solutions in our general solution as well. So for this one, we have b here, and the equation that we're dealing with is y double prime plus 8y prime plus 16y equals 0. So this is my equation, and just like the previous video, I'm not going to go into depth about the solution parameters that we talked about, but you have to realize that these are solutions. So y equals e to the mt, y prime equals m e to the mt, and then y double prime equals m times m, which is m squared e to the mt. And these are solutions that we can plug into our original homogeneous differential equation to solve for the roots. And in this time around, we might encounter where we have some distinct roots, or we might have some complex roots, which we're going to discuss in other videos. So right now, just like last time, we're going to plug our solutions here into our original equation, and it's going to end up looking like this. We're going to get m squared e to the mt plus 8y prime, y prime is m e to the mt plus 16e to the mt equals 0. So again, we can factor out the e to the mt, and then that will lead us to the auxiliary equation, which we can solve for the roots. So then let's factor the we're going to factor out e to the mt here. Inside we'll be left with m squared plus 8m plus 16 equals 0. And then therefore my auxiliary equation is going to be m squared plus 8m plus 16. So now I can factor this, find my roots, and then I can solve for my general equation. So you'll notice this is not too hard. Factoring this, I know that I'll have an m term here, m term here, and it's going to be equal to 0. And from inspection, I know that I need two numbers that add to 8 but multiply to 16. So the first number that pops into my head is 4. So I get a positive 4 here and a positive 4 here. Now if we check, m times m is m squared, we get a 4m here, another 4m, so that makes 8m, and then 16, 4 times 4 is 16, so it works. So this is a solution. You can rewrite this as m plus 4 squared equals 0. And if you take the square root of both sides, you'll realize that you are going to get two roots, but they're both going to be -4. So therefore m1 equals m2, which equals -4. So in this case, we have a case where we're repeating roots, and there's a proof in the textbook that tells us how to write out our solution when we have two repeating roots. And it's not going to be, like the distinct roots where we write one and then another. With when we have repeating roots, I'm not going to do the proof here, but you have to add on another kind of equation to one of your solutions to make sure they're different. Because you want to make sure that for each solution you have a distinct, linearly independent solution, and you don't want to have something that looks the same, because then you're showing that, okay, you have a solution, but it's not independent from the other solution. So I'll write down what I'm talking about here. So our solution for this case is going to be equal to y, c, which equals y, and then it's going to be equal to c1, e, our first root again is negative 4t, and then for our second root we're just going to add it on. We can add a second arbitrary constant, c2, and then we have e to the negative 4t, and then we're going to multiply it by, let's say, x. So if I rewrite this, c1 e negative 4t plus c2 x e negative 4t, and that's our solution. So again, you might be asking, why did I multiply by x? It's just another kind of thing that I'm multiplying this by to eliminate both of them looking the same, because we want them to be distinct. Even though that the roots are repeating, if you plug this solution into the original homogeneous equation, you'll get that the left side equals the right side, and same thing with this. The reason you multiply by the x is just to make them distinct, and like I said, it'll still verify. So that was the second problem, and I'll go over a couple more. We might jump into YP in the next video, but thanks for watching. Okay.